So first up is a phase diagram. A phase diagram basically tells you where the solid, liquid, and gases are. Okay, so I'm actually going to go and add a blank paper here, and I want you to take some notes because you're going to need these to be able to understand that worksheet that I just showed you. So we're going to start with a basic phase diagram. And you're going to want to make it big because we're going to be writing lots of stuff on it. Okay? So here's my basic phase diagram. Up this side is pressure. Down this side right here is temperature. It's a U. Did I spell that right? For some reason it's not looking right. Okay. I forgot the A, that's why it doesn't look right. Okay. Now, what we're going to do is we're going to label this. So, first up, we need to label the areas. This is a solid area. This is where things are liquid. And this is where things are gas. Now, knowing that, what's this line between solid and liquid going to be? What happens when I go from a solid to a liquid? What am I doing? Melt. So going this way, I'm going to melt. What if I go that way? What am I going to do? If I go from a liquid to a solid? Freeze. Okay, what if I go from a liquid to a gas? What am I doing? Evaporate or boiling? What if I'm going this way? Condensation. Okay, now this is a harder one. What if I go from solid to gas? What is that called? Solid to gas. No. Starts with an S, but it's not solidification. I'm not solidifying anything. Sublimation. Sublimation. Now, here's the harder one. What happens when I go from gas to solid? Starts with a D. This is actually deposition. And the way to remember it is it's depositing. Okay, deposition. I'm depositing from a gas to a solid. When we make dry ice, we're taking a CO2 gas and putting a lot of pressure on it and making a solid. Really cool. Sublimation is when dry ice is just left out. What happens? You don't get a liquid phase, it just goes away. Okay? All right, so let's look at a couple other places on here that we need to worry about. If I come across at 1 atmosphere, that's standard pressure. If I come across here at 1 atmosphere, then the point I hit right here is called normal melting point. Normal melting point at 1 atmosphere. 1 atmosphere is just standard pressure. So if I go across at standard pressure and I hit this first line, that's normal melting point. What do you think this point would be? Normal boiling point. Okay, there's two other parts on here that we need to know. And I'm going to put them in red because they're important. First one is up here at the end here. This point is called the critical point. And I can get from that a critical temperature and a critical pressure. Okay? Critical temperature and pressure, that critical point, no matter how much pressure I put on the gas past that point, it's going to be gas. I've got too much energy, it's too hot, I can't make it anything but gas. Okay, it's got too much energy. All right, now this other point right here, where they all meet, this is known as the triple point. And it's a triple point because there's three things that exist at that point. a solid, a liquid, and a gas. That's why it's called a triple point. I can, in other words, if I get the right pressure and the right temperature, boil ice water. Okay, so if I have the right pressure and the right temperature, I can boil ice water. And I have gas, liquid, and solid. Which is pretty cool. This is a phase diagram. So label it so you go back in your notes. If you need to use it, you can use it. Because we're going to be learning a lot of different diagrams in the next couple weeks. So phase diagram. Now we're going to go back and we're going to look at the worksheet that you're going to be doing. Basically, using these diagrams is just being able to read a graph. If you can read a graph, you can do the ACT, the SAT, all the things that you need to do to get into college. So going back, here we have 3 graphs. Okay, so everybody's looking at your worksheet now. Keep your notes close because we're going to come back and forth. Okay, so on this first one, what is a stable state? Let me change colors. Stable state for substance A at room conditions, which is 1 atmosphere and 25 degrees. So what do I have to do? I have to come to A, and at 1 atmosphere and at 25 degrees, I connect, and where am I? Solid. Okay, so I put over here, I put solid. Now down at the bottom are all the answers, so make sure you cross out an S for solid. Okay? See the answers down at the bottom? Cross out an S for solid. It's the very first one. Now, you can probably answer most of these. I want to go to this one, though, number 4, because this one has confused a lot of kids. What does MP stand for? What is BP standing for? Boiling point. What does SP stand for? Sublimation point. Now, if I have a melting and a boiling point, will I have a sublimation point? No, because that means I am up here on the graph. And the sublimation point's down here, right? So if I have a sublimation point, am I going to have a boiling and a melting point? No. Okay, so let's look at, erase this real quick. Okay, let's look at this first one. I'm looking at 1 atmosphere, so I'm going to go across right here at 1 atmosphere. Just before I put any numbers down, what do I know I'm not going to have? Sublimation. So right in sublimation, I'm going to put Na, and I'm going to cross out one of my Nas down at the bottom. Okay? Did you pick up the worksheets at the back? Go grab them real quick because we're doing them. Okay? So now what I'm going to do is I'm going to go at 1 atmosphere, and I'm going to come, and oh, that's right on that line, which has to be 40. Is there 40 down at the bottom? Okay, so that's got to be my 40. So I'm going to put melting point as 40 degrees. I'm going to cross that 40 off at the bottom. I'm going to come over here to boiling point, and it's about right here coming down, right? What's close to 80 down at the bottom? 81. So I put 81 here, and I cross it out. Okay, I want to go down to the very last question on this worksheet. What does it say? How is a phase diagram like a map? Okay, give me some ideas. It's in a grid. What else? Use it to find things. Okay, what else? It sort of uses coordinates like a map, right? What else? Someone said yesterday that it sort of like boundaries, like state boundaries. It shows you boundaries like counties or state. It's also like a road, right? So if I follow the road, I know I'm in between states kind of thing. Whatever you put there, make sure that you relate it somehow to a map. So you're going to be doing this. Everybody understand how to read this map and what it means, or how to read this phase diagram. Okay, so we're going to go forward here, and we're going to talk about the next one. I know it says honors. Just ignore that part because the regular one I didn't have enough time to fix all the colors on it. This part right here where it tells you all the colors and stuff. And the regular one didn't have a lot of room to do stuff in. It had the same things on it, but the honors just had more room to draw, and you're going to want room to draw. Okay? So you're going to be using a model kit that looks like this. Okay? And those are underneath the honors chemistry crate over on the far side. So what I'm going to do is I'm going to take you through a couple. Now, these kits were bought before I came to this school, and they're the lower version of the kits, so they don't have all the things that you need. So I'm going to walk you through the ones that you're not going to be able to make. Okay, there's just not the things in there that you need. So the others you're going to need to make yourself. So looking at this first one, let me get it on here. This is one that you cannot make because they don't have a molecule on there for you to make. This is also where your green sheet that has all the angles and stuff, this is where you're going to be using it. So we're going back to what we learned, how to draw Lewis dot. How many remember that? A few, good. So if I have this first one, BE, how many Lewis dots are around it? Look at where BE is. How many are around it?
Two.
Just two. So I just worry about what's on that row that the element's on and what's in the first two columns and the last six. I ignore the D, I ignore the F. So it's just the S and the P. So the first two columns and the last six. So to get to beryllium, it's just lithium then beryllium. So I only have two. Since there's two, I put them as far apart as possible. So one on each side. How many does fluorine have? How many does fluorine have? See where fluorine is. You have to count everything on that row to get to it.
7.
7. It should be 7. So 2 in the S, and 1, 2, 3, 4, 5 in the P. So I go through lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. That's 7, right? It needs one more. Remember, all elements are trying to get how many in their outer shell? 8, an outer octet. So it wants one more. So I'm going to have a fluorine come right here and a fluorine come right here, right? Now beryllium still won't get to 8, but all it has is 2, so it can only open up 2 orbits. So it's got as many as it possibly can. So what happens over here is what we're going to draw. And you usually would use color, and I'll let you get colored pencils here in a minute, but we're just going to use black for this right now. Okay, we're going to do an open space right here for beryllium. And then we're going to use, and it usually would be green for fluorine, green out here, and a green out here. Okay, and you can leave them open so when you get your coloring, you can color it green. Okay, and beryllium we usually do a tan or brown. Okay. All right, now what was my central atom? Beryllium, so I put Be. How many bonds did beryllium make? 2. What was this bond angle here? What was that bond angle? 180, good. And what was the shape of the molecule? Linear, yes. Now if I don't know, I can look on that green sheet and figure it out. Okay, we're also going to do the next one because I'm going to make that eraser bigger. Because the next one also is one that you cannot make. Like I said, it wasn't my choice to have this model kit. So, boron. How many does boron have around it? 3. So, how do I place 3 around? Equally spaced. What shape? Triangle. 1, 2, 3. Right? Yep, you're up here by Kaysen. Okay, and we still have fluorine, and fluorine had how many around it? Making you think. 7. 2, 3, 4, 5, 6, 7. So I'm going to put a fluorine right here, and a fluorine, whoops, whoa, that was good. Fluorine right here, and a fluorine up here. Okay, so what it's going to look like over here is the center and I'm going to have a fluorine here, and a fluorine here, and a fluorine here. So if I color it, I'm still going to use that gray or tan for the center, and I'm going to use the green for my fluorine. Okay, what was my central atom? B. How many? 3 bonds. What is the angle? The angle is 120, and the shape is trigonal planar. Now, if you didn't know that, that green sheet is one that will help you. Okay, so we're going to go on to the next part over here. The next 3 you should be able to make, but the last 2 on that front page you will not be able to. So let's look at those last 2. Okay, so we got phosphorus and sulfur. We call them PS, by the way, they're the party group. That's because they don't follow normal rules. Normal rules say I want 8 around me. Well, PS, they like to have more than 8 around them. More the merrier. So, let's look at phosphorus first. How many does phosphorus have around it? 5. Good. So 2 in the S and 1, 2, 3 in the P. How many does chlorine? 7. This is in the same family as fluorine, right? So it'll have the same amount. Whoops, one more. Okay, so what I'm going to do is I'm going to come and put a chlorine here, a chlorine here, a chlorine here. I still have 2 more chlorines to put in. So what I have to do is I have to split this group right here and put a chlorine here and a chlorine here. Now that looks like a mess, right? So as I go to draw it over here, what is actually the shape is I've got 1 coming up, 1 going down, and then on the plane here I actually make a triangle. So I'm going to put 1 coming out, 1 going back, that's a dotted line, and 1 coming out, and that's sort of a V. So what you've got is basically that shape. So if I take and cut a paper, let me see if I can cut a paper here for you. I'll use this one. And I take a pencil and I poke it through the triangle-shaped paper. That's the shape I've got. Okay, whatever, pen, pencil. Okay, so what I'm getting is in the center where they all meet right here, that's where my phosphorus is. And then on each of the corners is where my chlorine would be. All right, now, what angles do I have? Or what's first, how many bonds, right? I don't have my things at the top. Of central atom first. Phosphorus, how many bonds? 5. And what are the angles? There's a 90 and there's a what? Good. This one right here is 90, and this angle from here to here is 120. So there's a 120. What shape is this? Look at your green sheet. What shape is this? It's not right. Trigonal. Yes. 90 is because this angle from here to here is 90, but the triangle around the center, the angles between the 2 chlorines on each end, right here and here, those angles are going to be 120. Okay, so if I take, let's see if I go here and here and here, this right here actually makes a flat plane. Okay, all right. So we got that one. Let's do the next one down. I'm going to, well, we'll just erase all this. Okay, so sulfur, how many around it? And I forgot to color my fluorine here. or my chlorine. We'll color them. And we'll color that. Okay. How many around sulfur? 6. 1, 2, 3, 4, 5, 6. And then we have fluorine. How many around fluorine again? 7. 1, 2, 3, 4, 5, 6, 7, right? So I know fluorine will go here. I know fluorine will go here. But that's only 2 out of the 6 that they want me to put around it. So I got to split each of these others. So I'm going to put fluorine here, and a fluorine here, and a fluorine here, and a fluorine here. Told you it was a party animal, right? Okay. What this is going to do is it's going to get a shape like this. The up and down, but on the plane area we're going to have a square. Okay? So as I'm looking at it here, I'm going to have a center. I'm going to have one chlorine up, or fluorine, sorry, one fluorine down. I'm going to have back into the plane of fluorine. I'm going to have coming out of the plane of fluorine. I'm going to have back into the plane of fluorine and coming out of the plane here of fluorine. So this area right here, let's do yellow. This area right here is a square that is in a plane. Okay? So we're going to color our fluorines green, and our sulfur, sulfur likes to be yellow. So we're going to color it yellow. All right, central atom. Sulfur, how many bonds? 6. What is the angle? 90. It's just all 90s. Okay, let me show you what it looks like. This is a model right here. I'm going to put it under here for a second. Okay, this is a model of what that is. If you hold it like this, you can sort of see that this part right here is a plane. It's all in one level. Okay, so if I do this, you can sort of see this right here is all in a plane. Okay, it reminds me of a top. You can play with it that way. But this is the shape. Okay, so you sort of see it sideways like this. The easiest way to draw it is the way I showed you. Okay, so right here, it has a special name. Can you find the name on your green sheet? Octahedral. Okay, now I've helped you through a couple of them. You're going to actually make some of the others. Now, as you're looking at this, I've actually gone through and done part of this back sheet, but I didn't tell you. Because the back sheet here is drawing the Lewis diagrams, just like we did over here in the corner, over here, for the first one. So you're going to have to redraw them the way that we did. Okay, we have been. So if you had looked ahead, you could have done that, but I want you to do it. Yes?
Okay, so if it's like, let's say it has 90 degrees, is it an octahedral?
If you have the 6 things attached, it's octahedral.
So like,
so you need to go to the 3rd row from the right to get the actual shape. From the right. Okay. So if you look at the geometry name, the VSEPR class, the A is the center molecule, the X is how many things are attached to it, and the E is the unshared pairs of electrons that are there. So I want to show you really quickly polar and nonpolar. So if I were to do nitrogen with hydrogen, nitrogen has how many around it? How many does nitrogen have around it, guys? How many around it? 5. 2 in the S, 1, 2, 3 in the P. How many does hydrogen have around it? 1. So if I put hydrogen here, I'm going to get this. Now, if we were just to draw the Lewis dot of it, we wouldn't know if it's polar or not. Polar means that I can cut the nitrogen away from the hydrogen. In this diagram, it doesn't look like I can. But when we go and make the molecule, we'll actually get nitrogen, which is blue, and we'll have a hydrogen here, a hydrogen back in, and a hydrogen out again. So I can actually cut the nitrogen away from the hydrogen, okay? If I can do that, it is polar because the nitrogen wants electrons, so this side will be slightly negative. Now that's a funny symbol. All it is, how many of you have seen a delta, a capital delta, the triangle? This is a small delta, so it's a slight positive or slight negative. And this side has hydrogen, so it's a slight positive. So it does have poles. If I can't cut it away from each other, this was an example of NH3. This part right here represents an unshared pair of electrons. Some of your kits will have these, some of them won't. Some of them won't. Okay, so we need to make sure that if you have an unshared pair of electrons, just put a gray thing there and don't put a knobby on the end. Okay? Now, we can look at this one. Is this polar or nonpolar? Can I count the white? Can I cut with one cut the white away from the green? No. So what is it? Polar or nonpolar? Nonpolar. How about this one? Polar or nonpolar? Polar, because I can cut that red away from the white. What about this one? Polar or nonpolar? Nonpolar. Okay, so on this one, that's what you're going to do.
So H2O, like, that one is strong, like, yeah, that, yeah. So
Okay? Okay, questions? We're going to be working on this lab for the next couple days. The phase diagram is due next time. Okay? So do the phase diagram first, then go get the kit and start working on the lab. Okay? Questions? Okay, time is yours.